Okay, in this lesson we're going to be looking at what's called finite differences. In the past we've looked at situations where they give us an equation and we can use that equation to identify what the degree of the polynomial is going to be. But in this lesson they're going to give us the data that would fit into a polynomial. And we need to figure out whether or not the polynomial exists, and if so, what would the degree of the polynomial end up being. Now let's say, for example, we didn't know what these equations were. So if this was all we were given, was just this data. The finite difference theorem, what it's going to do is it's going to do two things, and that's what's highlighted down here. It's going to do what's called, it'll tell us if a polynomial exists, and it'll tell us what the degree of that polynomial would be. And the way that we do that is we subtract. That's why it's called finite differences. We subtract one term minus the one before it. So for example, 70 minus 14 is 56. 144 minus 70 is 74. 164 minus 144 is 20. 10 minus 164 is negative 154, so it's okay to have negative numbers. Negative 486 minus 10 is negative 496, and negative 1540 minus 486 gives us negative 1054, which gives us this first row. Well, if you notice in this first row, we don't have anything in common, so we're just going to go on again. We're going to take and find the next set of differences. 74 minus 56 is 18. 20 minus 74 is negative 54, and so on. And again, if you notice in the second row, we don't have any of the same numbers, so we're going to move on to the next, find out what the next row of differences would be. Negative 54 minus 18 is negative 72. Negative 174 minus negative 54 is negative 120, and so on. Again, nothing in particular stands out here, so we're going to do this again. If I take negative 120 minus negative 72, it gives me negative 48. Negative 168 minus negative 120 gives us also negative 48. And negative 216 minus negative 168, that also gives us negative 48. So if you notice, our fourth row of differences are all equal. Now that does not mean the degree of the polynomial is going to be negative 48. What that means is, since it's the fourth difference, the degree of this polynomial, if you look back at the original one, the degree is going to be 4. So the row of differences, when they're all the same, tells you what the degree of the polynomial is. And if we were to keep going, and like let's say if the fourth row of differences weren't equal, if I were to keep going and if I'm just not finding something that works, that means that a polynomial does not exist that would give us those values. Therefore, it's really important when we're doing these to make sure that you're probably using a calculator, because one little mistake at the very beginning or any time here would end up throwing off your answer. So it's super important to make sure that you're getting these precise. So you want to make sure that you're using your calculator here. Let's look at the next one here. They did this one for us. 5 minus negative 3 is 8. 13 minus 5 is 8. 21 minus 13 is 8. 21 minus 21 is 8. Sure enough, our first differences are all equal, and if you look at the actual equation, it is a first degree polynomial. That's what this would have found. So let's do one together here. And by the way, when we're doing this, we don't care about the independent variable. What we learn about tomorrow, that's going to come into play, or in the next video. But in the what we want to concern ourselves with is the dependent variable, the bottom row here. So what I'm going to do is we're going to take and find these differences. So you want to make sure that you're probably using a calculator for some of these. A lot of these you'll be able to do without a calculator. Like 8 minus 0, you should be able to do that is 8. 33 minus 8, well that's 25. 75 minus 33 is 42. Might need a calculator for this one. 134 minus 75 is 59. So now I want to find the next row of differences. 25 minus 8 is 17. 42 minus 25, well that's also 17. 59 minus 42, that's also 17. So the fact that I have a row of 17s and it's my second row of differences, remember we do not count this one. We start with this one, so this is 1, 2, our second row of differences are the same. It means it's a second degree polynomial. Why don't you try this one on your own? So why don't you take a minute? You probably want to use a calculator for some of these that deal with some larger numbers, and see if you can figure out whether or not we can make a polynomial out of this, and if so, what would the degree be? So pause the video and hit play when you're ready to check your answer. Okay, so here's what you should have done. The first row of differences would be these: 7, 19, 37, 61, and 91. The second row of differences would end up being, well, 19 minus 7 is 12, 37 minus 19 is 18, 24 and 30. And lastly, 18 minus 24 is 6, 24 minus 18 is 6, 30 minus 24 is 6. So we get our evil 666 here. But that just tells us that this is a third degree polynomial because it's the third row of differences that we got that row of 6s. So this would be a third degree polynomial for this one. Now, what if they don't give us a table? What if we need to come up with the numbers on our own? Let's look at this example. This will be the last one we do. So in this one, they ask us to find the first 7 terms in the sequence. Well, don't overlook the obvious. Remember, this is a recursive formula. So they give us the first term here is going to be 3. The next term in the sequence, this is telling us to double or multiply the previous term times 2, and then add 1. Well, if I take 3 times 2, I get 6, and add 1, I get 7. Then I multiply 2 times the previous term, which is now 7, and add 1. So 2 times 7 is 14, plus 1 is 15. And I double that and add 1, so that'll give me 31. So the next term would be 63. The next term then would be double 63, which is 126, plus 1 is 127, leaving us with our last term of 255. Okay, next. This is where that's not your row of differences though, that's just coming up with the first 7 terms in the sequence. So this is our first row of differences. 7 minus 3 is 4. 15 minus 7 is 8. 31 minus 15 is 16. 31 minus 15 is 63 minus 31 is 32. 127 minus 63 is 64. And 255 minus 127 is 128. Our first row of differences. Our next row of differences, we're going to subtract these from each other. 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. You might notice a pattern here. Oops, missed one. This would be 32, and this would be 64. If I do this again, notice we're just going to start spinning our tires because 8 minus 4 is 4. 16 minus 8 is 8. 32 minus 16 is 16. This would be 32. So we just continue the cycle over and over and over again. So this would be a situation where there's not a polynomial. So there's not a polynomial that exists that would give us those 7 numbers, the 3, 7, 15, 31, 63, 127, and so on. Okay, so that is this finite difference theorem. So this again helps us find the degree, or first off it tells us if it is possible to have a polynomial. And if it is possible, it tells us what the degree of the polynomial is based on its row of differences that end up with the same value. So with that, that is your lesson. So good luck on your assignment.